So lesson 27, page 113. So let's piggyback on stuff we've already done. We're going to work on some more equations, and we will be good to go. So today we'll start off with the distributive property, something we've already done, but to refresh your brain, the distributive property is the art of taking care of this stuff. We could solve this problem two ways. If I branch this off here or here, I could solve this problem way number one by going 4 times 2 plus 7, which is 9, which equals 36. If I branch off this way, I can also solve this problem another way by distributing the 4. I can distribute the 4 so I get 8 plus 28, which gives me 36, right? So I can get the problem two ways. I can get this by adding 2 plus 7, right? To get 9, multiplying that by 4. Or I can do 4 times 2 plus 4 times 7, which gave me 8 plus 28, and get 36. Right? So I can get that problem two different ways. All right. That's the distributive property. That's something we've been doing that. We can use that distributive property to do something more difficult, which is what we're going to do. Let's do something more difficult. Let's expand something. That's supposed to be a z. All right, so we got xy, and then times y squared minus x squared z. And our job is to use the distributive property to expand this thing. So when I expand it, I'll show you the first step so that you can see it, and then we can solve it from there. Our first expansion is to take xy and multiply that times y squared, which is what I just wrote. And then again, xy, because I'm doing it twice, times minus negative x, well, I don't have to do negative, x squared z. I kind of made a mess of that. Okay? If I want to do it algebraically, I'm going to rewrite this so I can say xy times y squared plus xy and then negative x squared z, which is what I was trying to say before, and then I messed up my brain. So this is the algebraic. This one is the one I would say you need to indicate that you need to be doing. Remember, algebraic addition, we'll change that to the negative, right? Okay. So where do we get as an answer at this point? We get, we'll do the multiplication on the first one first. So we get x, y to the third, because I got 3 y's. And then minus, because this is going to be a negative answer, x to the third, y, z. Okay? So x, y to the third minus x to the third, y, z. Any questions on that? Cool. Let's try something else. How about 4x, y to the third times x to the fourth, y minus 5x. A lot of mishmash there. We're going to do it the exact same way I did the last problem. So 4x, y to the third times x to the fourth, y plus 4x, y to the third times negative 5x. With me so far? All right. So start with this. Start here. 4 X to the fifth. Good. Y to the. And now over here, negative 20 x to the second, y to the third. Done. Okay? Now let's do one more without doing that middle step that I just did. We don't need to. And just for giggles, we do it reverse.
For giggles.
So we'll do it reverse. Let's do it all in our head. We're going to multiply here and there. And we're going to keep it in the same format we did before. So here we go. 2 for my 2. And then we could say AYX squared, right? Minus 8 x squared y to the 6.
One on the first problem, though, y squared.
Did I forget to square it? You're right, I did. Thank you for correcting me. I forgot to square the y. Thanks for the correction. It's easy to miss something. Got it?
Mm-hmm.
Pretty easy, right?
Mm-hmm.
All right, so let's transition to the next thing. We've been doing equations for a while. We're just still doing some fundamentals. Here's another equation. Everything's decimal, right? We can make this problem a lot easier on us to solve if we can get rid of all the decimals. So let's get rid of all the decimals. So I'm going to multiply every single term by 100. Well, where did I get 100 from? I didn't pull it out of my foot. I multiply by 100 because this is in the hundreds place. Okay? So this is 40 plus 2m equals 460. I move the decimal twice for 100, right? I had to do 100 to get this one. That's the one I was looking at. That was my smallest decimal. That was my goal. Okay, now I can solve it as if I had been solving them. Minus 40 on both sides, I get 2m equals 420. Divide by 2 on both sides. M equals 210. Very good. Would I have gotten 210 if I had done this one the exact same way? Nod your heads, yes, because I would have. Okay, all I did was get them all in an easier format to do.
Would we have gotten exactly 210?
You would have gotten 210. It's always going to be the same answer. We're doing the exact same thing to all the problems. When we do that, we're not changing the answer. If it was changing the answer, it would be something that we should not be doing. How many decimal places this time? I need to multiply by what? 1,000. So this gives me 2k plus 20 equals 4,020. Big numbers, but a lot easier to do than the decimals. So 2k equals, doing it in our heads, 4,000. K equals 2,000. Pretty cool, huh? If you want proof of that, where'd it go? When proof of that, we could always do 4.02 minus 0.02 equals that, equals 4. And then I'm going to divide that by 0.002. And I got 2,000. Okay? But this is a lot easier, isn't it? So, since you can't use the calculators, would you like me to say do all these like this, or to do this and get the same answer? I think doing this is a lot easier. Okay? What's the rule to remember when you do those? Well, it is, you look for the smallest decimal, but what's the rule? You've got to do it to everything. Okay? With equations, because we want to keep them equal, that equal sign tells us they're equal, we got to do it to everything. It's kind of like applying the golden rule to equations. Do unto others as you would want done to you. Okay? So you're going to do unto others the exact same thing. Okay? You're going to be fair. Unlike our government. Questions? All right, you're done.